Testing. Test. Can you hear me? Should be able to, right? Okay. Welcome to our APMOPS 2026 going through of the questions. Now for today, I will wait. Let me check my microphone again. Okay. My microphone is working very nice. Okay, so for today, what I will be doing is that I'll be going through this, right? And I'll try to go through fast because of the fact that you all are starting at around like what time is it now? 7:30 already, and it takes quite long to go through all these questions, and I really want you all to just go and rest once you are done with the actual competition itself. So let's start going through. I'll try to fly through the first 10 questions as fast as I can, basically. Okay, question number 1. Two positive integers satisfy 5/6 of one of them equals to 1/4 of the other one. So if I call the first one as A, 5/6 of A is 1/4 of the other one, which is equals to B. Then find the minimum possible value of the sum of these two integers. I want to minimize the value of A plus B, yeah? Okay, so we can take the first one, we can clear the fraction that multiplies by 12 because 12 is the LCM of 4 and 6. Then what I have is going to be 10A equals to 3B. So if here A and B are integers, what can we tell? We can tell that in fact the minimum value of A is 3 and then B is 10, right? Because 10 times 3 is 3 times 10. So the minimum value of A plus B is 13. Finish. Okay, let's continue on. Next one, question number 2. Quite similar to question number 1, we also use algebra for this question. A factory's total income last year exceeded its total expense by this is $12,000. It is estimated that this year, the total income will increase by 30%. So that's going to be how much? 1.3, right? In other words, 13 over 10. Total expense will decrease by 20%, so it will become 4 over 5. And now that this year's total income will exceed total expense by 20,000. So that's what the question is telling you. Okay, now what we can do to find income of factory last year, which is the letter I, we can try to eliminate the letter E, right? How to do that? We can multiply the first one by a value of 4 and then multiply the second one by a value of 5 so that the E becomes the same thing. So by doing that, my first one becomes 4I minus 4E is equals to 48,000. My second one becomes 13 over 10 times 5 is 6.5. In fact, 6.5I minus 4E is equals to 100,000. So taking the difference, we can figure out, okay, 2.5 times of I will be equals to the difference of 100,000 and 48,000, right, which is 52,000. And from there, we figure out that, oh, I must be equals to 52,000 divided by 2.5. You can figure out that's equals to 20800. Finish. Okay, thank you, Liu Anti. Okay, next, let's continue on to question number 3. Two circles whose difference in areas is 169, the ratio of the circumference is 7:6. So if the ratio of circumference is 7:6, what happens? Then I think you can easily see that the radius will also be 7:6, right? We don't care about the actual length, we just care about the ratio. And that means that the area ratio will be 7 squared to 6 squared. It will be 49 to 36. And if the area ratio is 49 to 36, then the 13 units of difference is the 169 square centimeters. Okay. In that case, 1 unit is equal to 13, and so that means that the final answer we're looking for, the area of the smaller circle is 36 units, which is 36 times 13. This is equals to 360 plus 108, 468. Okay, continuing on. Question number 4. When 246 is added to reverse 642, the sum is 888. Find the largest one so that the sum of the integer and reverse is 786. So let's say we have ABC, and then the reverse will be CBA. Now one thing to take note is that behind says A plus C is 6, but in front says A plus C is 7. So what's going on? Well, the thing that's going on is that there must be a carryover. it must be a carryover of 1. And that means that, in fact, we know this value of b plus b is not 8, but rather 18. So in fact, we can immediately conclude it should be 9 and 9. That gives you the 18, right? And then now a plus c is just the value of 6. Since both of them cannot be 0, the largest value of a is what? Is 5. Or we can choose 591 together with 195, and we can check that that one will be 786. So the largest one is 591. Auntie bad, you shouldn't be spamming. I was just about to praise you, so no, thank you. Okay, anyway, let's continue. Question number 5. Towns A, B, C, D lie in this order along a straight road. It is known that distance from A to B is 3/5 the distance from C to D. So let's say that A, B, C, D, they are like that. Now, I'm not going to bother drawing it to scale. Okay. The first one tells us 3 to 5, so it's 3 units, 5 units. Then the distance from A to C is, say it together. Okay, don't say it. Okay, so from this ratio here, what we can figure out that is that the difference is actually just going to be 2 units. Alright, because of the fact that the one on top includes what? It includes the extra 5 units, right? But the one at the bottom, it only includes the extra 3 units. So the difference between these two things is actually 2 units. So if these 2 units here, we can see that the difference between 6 parts, right, and 7 parts is going to be 2 units, then 1 part is 2 units. So that actually means that the 6 part here will be equals to 12 units, the 7 parts here will be equals to 14 units, right? And then now what we have is that the middle one is going to be 9 units. Okay, so then 9 units is equals to 36 km. We can figure out that the thing they're asking for, distance from A to D, is 17 units. This will be equals to, I think this is 68. Okay, right, let's continue on. 2 candles with the same thickness and material have initial lengths in the ratio 19 to 15, and they are lit at the same time and burn at the same constant rate. So same thickness, same constant rate means that they go down in length equally as fast. Right. So the initial 19 to 15 will go down the same length into 10 to 7. But of course, you can check 19 minus 15 is not 10 minus 7, right? So we need to make them equal difference. What we do is that we multiply this by 4, so that we can, by 3, so that we can get 57 to 45. Now they have a difference of 12. Meanwhile, 10 to 7, this ratio are multiplied by 4, so that it becomes 40 to 28. The difference is also 12. So therefore, we can see now, the part that has disappeared from both of the candles is the 17 units. So 17 units is 34. In that case, what do we want? We want how many more minutes does the longer candle need to burn completely? It still needs to burn for 40 units. So 40 units answer is 80 minutes. Finish. Okay, continuing on. 5 distinct integers are selected from the set such that the difference between any two numbers is not divisible by 5. How many different selections are possible? Okay, this one here takes a little bit of effort, but the first observation to notice is that actually you are given exactly 10 numbers. And if you have 10 numbers, each with a difference of 3, what happens? Okay, I forgot to tell you, it's divided by 5. That means that every single difference, or rather every single number is going to have, every single remainder is going to have 2 numbers, right? So that's what I'm trying to say. So if you actually bother to write it out, for example, this is what it looks like. Right. So remainder 0, you can see there's 2 numbers. Same thing for remainder 1, remainder 2, remainder 3, and remainder 4. So if I don't want the difference to be divisible by 5, means I cannot select both 10 and 25. I need to select at most one of them. I cannot select both 1 and 16. I need to select at most one of them. I cannot select both 7 and 22. I cannot select both of these. I cannot select both of these. Means I need how much? I need exactly 1 from each column. right? I need one from here, one from here, one from here, and so on. In that case, how many different ways? 2 to the power of 5. Right? 2 times 2 times 2 times 2 times 2, answer 32. Okay, I noticed a lot of you discussing about RMO and APMOPS. Personally, RMO is going to be generally harder, and this is true no matter which year it is. But some people, when they try the questions, they might find RMO a bit easier. That's their own personal preference. Anyway, question number 8. Let x, y, z be positive integers satisfying this equation. Find the value of 29x plus 30y plus 31z. Personally, I quite like this question because what's the idea? If you stare at this, you realize, okay, the difference is what? Can I try to find 10x plus 10y plus 10z? Right? If I can find this guy, I'm done, right? That helps us find the difference between here and here. But to find this guy, if you notice the expression we have, it looks almost like 4 times. So instead, can I find 40x plus 40y plus 40z? Well, firstly, this is a multiple of 40, right? And if you look at the question, you can see that it is approximately 567 because of the fact that this is approximately the same as just 39x plus 40y plus 41z. So since this is a competition question, we can very safely assume that this is just going to be 560. Right. Now, if you are not doing a competition, what do you need to do? For your own practice, you need to estimate to yourself why 520 is not possible, why 600 is not possible. But because this is a competition question, we can just take it as 560 and let's move on. In case you're wondering why these are not possible, is because if it's 520, then actually you can figure out something like z minus x is too big. If it's this one, I think z minus x is too small, something like that. Yeah. Okay, anyway, once you figure that out, you can divide by 4 and then figure out that 10x plus 10y plus 10z is 140. So that means that the final answer is 567 minus 140, which is 427. Okay, let's continue on. This question number 9. The first two terms of a sequence are 2016 and 2026. Starting from the third term, each term is the average of the two previous terms. Write down the integer closest to the 19th term of this sequence. Okay, for this question, if you actually try to work with the numbers 2016 and 2026, I can only say that you are very hardworking. Why I say that you are very hardworking? Because of the fact that you can make this problem easier for yourself. How to make it easier? Don't start with 2016 and 2026. Start with 0 and 10. Right? Because if you take the average, you don't really care about the exact value. You only care about how much difference they have, right? Does the fact that this is 2016 actually matter? No. We're going to do this, and then at the end, we're going to add my answer 2016. Right? Then the problem becomes a lot easier. So 0, 10, and then obviously 5, right? Then 10 plus 5 divided by 2 is 7.5. 5 plus 7.5 divided by 2 is equals to, this is what? 12.5 divided by 2 is 6.25, right? Then you add them together, it's 13.75. 13.75 divided by 2 is equals to 6.625, right? Is it? Did I make some calculation mistake? Sorry, it's not that. 6.875, I believe. Yeah. And then continue on. But at this point, you can already tell. The next one will be what? 6.5 something, right? 6.5. I cannot math. How much is this? 6.5625, something like that. Okay. By this point, you can already tell we don't need to figure out every single thing because we already know the closest integer. At this point onwards, you can pretty comfortably say the answer is going to be between 6.5 and 7, right? And if it's between 6.5 and 7, let me write it down actually. Between 6.5 and 7. Right. If it's between 6.5 and 7, then you already know, my closest number will be 7. Right? So closest will be 7. And then what I just need to do is I take this 7, I add it to my original 2016. The answer is 2023. Now, if any of you are curious, Even you're curious, in the future, you actually learn more about this. The exact number you end up with, in case anyone of you is figuring out, will be 6 and 2 over 3. Now, why is it 6 and 2 over 3? It's because of the fact that this is actually what we call a geometric series. A geometric series where we calculate the value of 10 times of 1 minus half plus 1 over 4 minus 1 over 8 plus 1 over 16 and so on. So in case any of you are curious, that's the reason why. But you don't have to know this now. It's just for your own understanding. Okay, question number 10. Let a and b be positive integers with b not equals to 1. If both a plus b and a plus b squared are perfect squares, find the smallest possible value of b. From these two conditions, you can see the a part is the same. So if I take the subtraction, I can tell that b squared minus b is the difference, right, of two squares. So then I ask myself, is this possible? Well, the square numbers, we have 0, 1, 4, 9, 16, and so on. For difference of two square numbers, what if you have 2 squared minus 2? Can 2 be the difference of two squares? No, right? What if you have 3 squared minus 3? Can 3 be the difference of two squares? Still no, right? What if you have 4 squared minus 4? Can this be the difference of two squares? Well, yes. Right. Okay. Yes, but the problem with this is what? The problem is that this will be 4, this will be 16, right? And if b is equals to 4, then it's actually going to be 0 plus 4 and 0 plus 16. Right? Okay, let me write it down. And the problem with this 0 plus 4 and the 0 plus 16 is that if you take a look at the numbers, wait, sorry. If you take a look at the numbers here, the a term is not a positive integer. So that is the problem. Right? So if a is not a positive integer, this doesn't work. Let's go look for the next one. b equals 5. 5 squared minus 5 is 20. Is there a 20 difference here? There is. Right. Okay, again, I'm not writing it down for some reason. There is a 20 difference here, and you can check this makes sense. Because if b is 5, you can choose your a to be what? A to be 11. Then you have 11 plus 5 is 16, right? 11 plus 25 is 36. So therefore, b equals to 5 is the smallest possible value. Okay. Okay. Hopefully you all can catch up for most of it, right? I went through it a little bit fast because I do have a lot of questions to go through. Now I'm going to slow down a little bit for 11 to 20. Yeah? Question number 11 here, evaluate the following expression. You should notice that the denominator is times 2, times 2, times 2, times 2, right? And each one of them is actually a multiple of 3. So step 1 is to take out the 1 over 3 and can recognize that it's now 1 half, 1 quarter, 1 over 8, and so on. And it stops at 384 divided by 2. 384 divided by 3, which is 128. Okay, now, once you get here, it is very well known that the thing inside here, this is actually 127 over 128. So then the final answer for this is going to be 128 times 1 over 3 times 127 over 128. So what's the answer? It's 127 over 3. Finish. Which is actually not a integer. Okay. Continuing on. Question number 12. This is kind of like a standard rate question because of the fact that it's quite common. You can see this kind of question in rate. So the idea for rate question is always to look at per unit time. In this case, which will be per minute. So let's take a look at per minute in this question. A per minute is how many? 1 over 6 of the job. B per minute is 1 over 7. C per minute is 1 over 8 of a part. Now, they are all going to work together to complete the job. And then when they complete this many parts, how many has A produced? So these are the individual rates. And we are only concerned about one thing, which is the ratio. So how to get the ratio? We multiply by the smallest common, by the lowest common multiple of 6, 7, 8. You can also do just times 6 times 7 times 8 is fine. But instead, I'll do times 24 and 7. So then in the end becomes, this is 4 times 7, that's 28. 1 over 7 times 24 times 7 is 24. Then this one times 24 times 7 is 21. So now the total of 3577 parts will be from taking 28 units, 24 units, and then 21 units together. Right? If you add up all these things together, this would be, I think, 73 units. Okay. Yes. I just saw some of your comments. I made a mistake for question number 11. Thank you for saying. No wonder. No wonder. My answer is not a whole number because this is wrong. Yes. The one in green color is wrong. What's the problem with the one in green color? It's not 127 over 128. It is actually 255 over 128. Right? Because of the fact that I forgot the existing 1 in front. Right? If you don't have the existing 1, then yes, it's 127. But because of the existing 1 in front, actually it's 255, right? So sorry about that. Let me make this change. Let me make this change. This is 255 actually. So this is 255. And then now our answer will be integer. Answer will be 255 over 3, which is equals to 85. Yeah, thanks to those of you who pointed out here. Okay. Anyway, let's continue on. After you add up A, B's, and C's rate, you can get 73 units. And 73 units should be the total of 3577 parts, right? So this is supposed to be 3577. Now you can divide and figure out that actually 1 unit will be equals to 49. Right? If you divide this by this, it's 49. How to see is 49? Actually, you can just do estimation. If you do 50 times 73, is how much? If you do 50 times 73 is 7300 divided by 2, right? That's going to be equals to 3650. And then from here to here, it's just minus 73, no? Right, so that's why 1 unit is 49. And then from there, we can figure out A will be 28 units. That's 28 times 49. Again, how to calculate this? 28 times 50 minus 28, right? The part in front is 1400 minus 28 is 1372. Okay, let's continue on. Okay, question number 13. Long phrasing. Right, long phrasing. Actually, I do not know the answer for this question yet because it was so long that I move on to other questions. But I do know how to do this. Okay. What's this saying? There's two teams, A and B. Right. A is only responsible for project A, B is only responsible for project B. On a sunny day, A can complete in 12 days. So A's per day is how many? Per day, A is 1 over 12. B complete in 15 days, so per day B is 1 over 15. However, there are some rainy days, right? On rainy days, A's efficiency decreases by 40%. So now I only have 60% left. So it is 1 over 20. B's efficiency decreases by 10%, so only got 9 over 10 left. The result here will be equals to 3 over 50. So now, the number of days they take to complete the job is here the same, right? They start and end on the same day. So means what? If I let the sunny days be something, let's call it X. If I let the rainy days be something, let's call it Y. Then I have two equations from here. For A, 1 over 12x and 1 over 20y can do the whole job. The whole job is considered as 1. Huh? For B's perspective, 1 over 15 of x and 3 over 50 of y can do the whole job. The whole job is once again 1. What do we want to find? We want to find the value of y because y is the number of rainy days, right? So we just need to get rid of x. How do I get rid of x? This thing here is 5 over 60. This thing here is 4 over 60. So we can get rid of it by doing this one times 4, this one times 5. So I'm going to multiply the first one by the value of 4, multiply this one by the value of 5, and then we can get 1 over 3x plus 1 over 5y is 1. Sorry, it's 4, I mean. And then 1 over 3x plus 3 over 10y is equals to 5, right? So from here, we can subtract and figure out that 1 over 10y, which is from this minus with this, is equals to 1. So then y is 10. Okay, very nice. Those who answered 10 are correct. Oh, why all of you so sad responses? Why got like probably fail, then start goofing around, then start doodling on paper? Why all sound so sad? Okay, anyway, continuing on, question number 14. A positive integer n is the product of two prime numbers. So normally you write this as n equals to p times q. It is given that the sum of all positive divisors of n is 3042. What are all the positive divisors? In fact, the factors, there's only 4 of them. 1, p, q, and pq. Right? There's only 4 of them. It is hard? Oh, that's unfortunate. Yeah, I think this is for at least for people who didn't do math Olympiad, this competition is pretty difficult. But for those who do this regularly, maybe at least you've seen some of them before. Huh? So anyway, coming back here, the factors are 1, p, q, and pq. The sum is what? The sum is in fact 1 plus p times 1 plus q. How to see that is because 1 times 1 is 1, right? 1 times p is p, 1 times q is q, and of course, p times q is pq, right? So the sum here is 3042. Now it seems that we don't have enough conditions to figure out p and q. After all, we just have one equation, right? But the key thing here is that these are prime numbers. What happens when p and q are prime numbers? Most of the time, p is going to be an odd number. So most of the time, 1 plus p is going to be an even number, right? So you expect to see even times even here. But if it's even times even, then you can expect to see the right hand side is a multiple of 4. But is 3042 a multiple of 4? The key idea is that this is not a multiple of 4. And when this is not a multiple of 4, then you realize, aha, then one of these numbers on the left is not even. One of these has actually to be an odd number. How to get odd number? Only way is to do 1 plus 2. The only way to get to odd number is to do 1 plus 2. Huh? And what does that mean for q? Well, 3042 you can now divide by 3. The other guy must then be 1014. So that means that p is 2, meanwhile q is 1013. And then when you multiply p and q together to get n, you get the favorite answer of 2026. Okay, continuing on. Find the number of 4-digit positive integers satisfying the following. Each of the first 3 digits is divisible by the last digit. So I want to have the number of a, b, c, d, where each of a, b, and c is divisible by d. Let's start from a simple case, d equals to 1. How many possibilities are there? Well, this is where most people can actually get wrong for this question, because of the fact that you can also use the digit 0. The digit 0 is divisible by 1. Right? In fact, 0 is a multiple of any number. Okay, so if d is equals to 1, you can check that, in fact, a will have 9 choices from 1 to 9, but b will in fact have 10 choices. And then c will in fact also have 10 choices. So in this case, it's actually 900. What about d equals to 2? D equals to 2, then what you can see is that a can only be 2, 4, 6, and 8. So there's 4 choices here. But b and c can be 0, 2, 4, 6, 8. So there's 5 choices. Continuing on, d equals to 3. A can be 3, 6, 9. But each of B and C has one more choice. So at this point, you can see where this is going. When D is 4, it can be 4 and 8. And then with the option of 0. When D is 5, A must be 5 as well. Then B and C can both be 0 as well. And then from here, you can see that actually the rest of the cases here, A only has one way, right? A must be equals to the number here in itself to be a multiple, right? So in each of these cases here, A will be one way, right? B and C, each of them will be two ways. Final answer, we have to go calculate it. And then this is 4, 4, 4, 4, 4. Right? So if you add up, let's say this is 1000, this is 70, I believe. Yes. Wait, no. Wait. 66 plus 4. Oh yeah, 70. So 1070 plus 16, 1086. That's the sum. For D equals to 2, won't B be equals to 10? No, because of the fact that B needs to be a multiple of D as well. Okay. Now question number 16. For question number 16 here, this one actually is quite a coincidence because I actually went through with my class this question a few days before the I use it as a kind of like preparation for the upcoming the SMOPS or RMO. I forgot which one it is. By the way, can anyone of you confirm? Is it 21 or is it 21 cube? I'm not sure which one is it. If any of you have the answer, you can tell me. Okay, now so how to do this question? So shout out to Xiong Jiangmin if you're here, right? Because I told you the idea already. But the idea is that we pretend that all these things that are minus are actually plus instead. All these things are minus, we pretend that they're plus. Okay? We pretend that they're plus, instead we're dealing with this kind of thing. The 19 cube, 20 cube, and then 21 cube. Now, what happens after we pretend that they're plus? It's actually not plus, right? So we need to subtract away. We need to subtract away one. We need to subtract away 2 copies each of these 2 cube, 4 cube, 6 cube, all the way until 20 cube, right? Because actually it's minus, it's not plus. So we need to change the plus to a minus. We need to subtract 2 copies of it. Okay, I think it's obvious I'm saying 21 cube. Okay, I trust you all. So then what we need to do here is that this term behind, we can factorize. We can factorize what? All of these are even numbers, right? So in fact, we can factorize out 2 from each of them. But because of the cube, we are actually factorizing out 2 cube, which is 8. So as a result, actually, we have 16 times of 1 cube plus 2 cube plus 3 cube plus all the way until 10 cube. So this is what we have. And now, for both of the things in front and behind, we can actually do this question. We can actually do this question. So what do we do here? We can do the one in front. The one in front is when n equals to 21. By the way, if any of you are curious where this is from, there's also something well known. This is in fact 1 plus 2 plus 3 all the way until n squared. So what is the thing in front going to be? In fact, it's going to be 21 times 22 over 2, and then you square it. So this is going to be 231 squared. Yeah, I think so. So 231 squared is equals to how much? A big number, right? 231 squared is equals to 200 times 262 plus 31 squared. 31 squared is 961. This is 52400, right? So it's 5253361. Yeah. Okay, 53361. And then minus off away this part here at the back, which is the case for n equals to 10. So we know that this is minus 16 times of 10 times 11 over 2 squared. That is equals to 55 squared. 55 squared is 3025. And then you have negative 16 times 3025, which is how much? Okay. I suddenly cannot do math. How much is this? 48,000, then 16 times 25 is 400. So it's 48400. Okay, hopefully I didn't do anything wrong. I might have though. Anyway, the final answer I get here is 4961. Probably. Okay. Continuing on, question number 17. Question number 17, we have a 20, 18, and 15 kind of figure. Point D is the middle of PC. Point EF, they trisect the line segment. So trisect means that it splits it into 3 equal parts. This is equal, this is equal, this is also equal. And then from there, we know that the lines CE and CF will intersect at G and H. Find the length of the segment GH. Well, the answer for this question is 6. The way you can do this thing is actually in some of our Sec 2 class, we teach this idea called a Menelau's theorem. If any of you are interested, you can go and read up about that. I will not be using it here today because for P6 students, it is easier for you to actually use similar triangles. So how to use similar triangles for this question? The way to use similar triangles is I want to be able to find out the ratios along this side. So we need to create similar triangles with these sides involved in those triangles. So what I'm going to do here is I'm going to draw a line through A that's parallel to BC. And then from that, we can extend some lines. We can extend CG over here, CH over here. Okay, let me draw that a bit better. So let's call these 2 points X and Y. Now, for this thing here, how do I find out exactly where J and H are is to use X and Y? How come? Because for G, we notice there's some kind of similarity. What's the similarity? Here. But that means that we need to figure out where X is first, right? How to figure out X? We can use another pair of similar triangles. I can use this pair of similar triangles to figure out X. Okay, so now what we can do here is that we can let this be 1 unit. And because of the fact that AE to ED is 1 to 2, hopefully you can see this is 1 to 2. We know that AX to CD must also be 1 to 2. So this is 2 units. But this is the midpoint, so this is also going to be 2 units. And that means that the shape I have right here, this comes back to this similar triangle here. What do you get? You get 1 to 4. You get 1 to 4. So from here, you can figure out that along the line segment AGB, it is 1 to 4. So actually, it is 4 and 16, right? It splits 1 to 4 here. Okay, why is the solution for all geometry mathematical questions draw random lines? Actually, you're correct. How to draw these random lines is something that you have to get more intuition with as the time goes by. One of you asked, isn't this butterfly model? Yeah, that's the correct thing. Okay, continuing on, we can also figure out the value of h. How to do that? Well, first we need to determine where is y, right? So we determine where is y by doing this one here. If you take a look at this, right, then we can see that actually FD to AF is 1 to 2. So then this thing to this thing must also be 1 to 2. So since we know that CD is equal to 2 units, we know that in fact AY must be 4 units. So in fact, let me just write down 3 units here, right? So that the entire thing is 4 units. And once we figure out that AY is 4 units, then we know that this is going to be, okay, let me try draw it again. These two now, right? You can see the ratio are going to be 4 to 4, right? It's 4 units on one side, it's 4 units on the other side. So we can figure out from here, what is it? We can figure out from here that H is the midpoint. It will split 1 to 1. So H is a point which splits it into 10 and 10. So from here we know, this length in the middle will just be equals to 10 minus away 4, which is equals to the value of 6. Finish. Why you're discussing which school you want to go? Very interesting. Okay. Anyway. Question number 18. This question number 18 is a logic question, but this logic question is not like your usual logic question. It's a bit tricky. It's a bit tricky because of the fact that we have A play 9 games, B play 6 games, and I want to find maximum possible total number of games that C can play. And each of them is 2 players play at a time. Unfortunately, the answer is not going to be 15. Some of you might have put down just 9 plus 6 equals 15, but it's not. Because it's not possible that C play with A, and then C play with B, and then C play with A, and then C play with B, and then C play with A, and then C play with B, and so on and so forth, right? Because of the fact that A plays 9 games, which is actually a lot more than 6. So it's not possible to alternate between CA and CB as the pairings of who is playing. What's the trick for this question then? This one I thought for a while, how to best present it to you all, because I was trying to find a way to explain this question. And I figured out that in fact, in this question, the best way is to look at who sits out. How come? Because the third player who is not playing will also come back and play the game again, right? You get replaced and play the game again. So the third player who is not playing will in fact go and switch in back and forth as well. Now, what is the situation you want with the last player who sits out? You want C to play as many as possible, so you want C to sit out as little of the time as possible. What you do now is that you slot in between A and B. A, B, this is sit out. Sit out, B will sit out 3 more times than A. Can you see that? Right, B will sit out 3 more times than A because of the fact that B played 3 games less. So B will sit out 3 more times than A, so you just start with B, and then you do B, A, B, A, B, A, until you hit 6 for A. So now you have 6 for A already. So you are done with A. What do you do now? For each of the subsequent times you want to use A, instead we use C. So this is the 7th B. This is the 8th B. And then this is the 9th B. And at this point of time, we can see that actually no. Wait, it's actually not entirely correct. This sequence is no. It's sorry, I made a mistake here. The mistake I made is something. The mistake I made is that B sits out 3 more times than A. But there's no need for B to sit out how many? There's no need for B to sit out for 9 games and A to sit out for 6 games, right? It just mentions that B sits out 3 more than A. So we don't know how many this is, right? We don't actually know. We don't know how many this is actually. We don't know. But then the thing at the back is that we need 3 more copies of B, 3 extra copies of B. So these 3 extra copies will come here, here, and here. And to fill in these 3 extra copies, you can see that C needs to sit out 2 times. And if C sits out 2 times, answer 9 plus 6 minus 2, 13. Finish. Right? Because they play, right? A and B play 15, right? But C sits out 2 times. So 13. Okay. This might take you a bit of time to wrap your head around it. But hopefully, if you try to let's say like rewatch this on a later date, you can understand what's my reasoning here by looking out who sits out. Okay, let's continue on. Question number 19. This question I started off on the wrong path on this question actually. The question is saying 6 red, 3 yellow. Jamie randomly selects 1 candy from the bag each time and eats it immediately. After she eats 4 candies, what's the probability that she has never ate a yellow candy after red candy? Well, that means you cannot have R followed by Y. Right? So initially what I do is that I go and figure out all the possible cases. But then soon I realized that actually the cases, they are not too bad to consider. I accidentally made a mistake here because I counted the number of cases wrongly. But actually there's only 4 of them. What are the 4 cases? You can have red, 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 red. In that case, you never eat a yellow after eating a red. You can have yellow, red, red, red. You can have yellow, yellow, red, red. You can have yellow, 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 red. And then you're done. Because there's no yellow, 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 right? It only goes up to 3 yellow candies. So the only 4 cases to consider are these 4. Why only these 4? Because once you start with a R, can you have a Y after that? Cannot, right? So you must continue with a R. Can you have a Y after that? Cannot. So you must continue with R. So at any point of time, if you have a R, it must continue with the letter R for the rest of the sequence, right? So these are the 4 possibilities. What are the probability? Well, we can go and count. R, 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 R. So 6/9 for the first case. Then after you remove the red one, how many do you have? You now have 5 here, right? And 3 here. That is 5/8. Then if you remove another red one, you have 4 here. You have 4 here, and then you have 3 here, so it's 4/7, and finally 3/6. That's the first case. Right. So let's simplify what this is. And in fact, you can see that this is 72. In fact, it's just 6 times 4 times 3. Right. So it's in fact 5/6 times 7. Like that. Second case, YRRR. This one, 3/9. This one, you have 8 left, and then there are 6 red, so it's 6/8. And then after you eat a red, there will be 5 red left, and then it's 7 pieces. And after that, 4 red left out of 6 pieces. So this is what we have. So here, once again, let's try to simplify. I think this is, once again, 5/42, right? Because if you notice, the numerator is the same, you just swap the order of the numerator. Okay. Yeah, I actually don't know why you are like subtracting marks away. Why not just like add? You should be happy, right? Positively oriented. You should be like happy. Yay, question 1 I can do plus 4 marks. Yay, question 2 I can do plus 4 marks. Why you're always like minus minus? Okay, anyway. Next one. Y again. So this is 3/9. And then this Y will be how many? 2 yellow candies from 8, right? So that's 2/8. Then this one goes back to 6 red candies out of 7. And then finally 5 red candies out of 6. Now at this point, you can very confidently say, actually my denominator, I already know what it is. It's just 9, 8, 7, 6 every time, isn't it? Right? It's just 9, 8, 7, 6 every time. By the way, the previous one here is 5/84 because if you compare the numerator, you notice the numerator is half of the previous one, right? So if the previous one is 5/42, next one will just be 5/84. Finally, this case here, that you will start with 3 yellow, then you'll drop the 2 yellow, then you drop the 1 yellow, which is the very last one here. And then finally, you have a 6 out of 6 chance, right? Hopefully you can see that. And so what would this be? Well, once again, if you compare the previous one and this one, you can see, just divide by 5, this is 1/84. So from here, the sum is equals to, out of 84 is 10, 10, 5, and 1. So this is 26, 13/42. And finally, what's the answer? 13 plus 42, this is 55. Okay, let's continue on. By the way, I see someone say in the messages, with very improper grammar, what is you guys with fail? And then after that, instead of Lamau, you say IMAO. Okay, very interesting. Okay, question number 20. The diagram shows a 90 by 90 square, and each side is divided into 3 equal parts. Some of these division points are connected in the figure, and then find the total area of the shaded region. Okay, so how to do this? Well, firstly, it is symmetric, right? So even though it looks a bit awkward, it's still symmetric. You can cut it up around here, you can cut it around here, you can cut it around here. Not very nice, but definitely can do it. But in fact, do you need to every single thing? Don't need, right? You can just focus on maybe this half. Then later on, we multiply our answer by 2, isn't it? Alright, focus on this half. Then we multiply answer by 2. So what is the area in this half? Okay, actually I didn't have time to try this question, so I need to think here for a while. Let me think here. Obviously I can cut it into half once again, but do I want to do that? Maybe. Yeah, maybe I want to focus on 1/4. But then like that, it's very hard to figure out exactly where these 2 points are, right? Oh, okay, I have an idea. So, okay, I have an idea now. So here I'm going to use a fact. This fact is actually very easy to remember, and I believe you all can also know why this is true. If you have a A to B kind of ratio, okay? If you have A to B kind of ratio, what is the ratio of the 4 areas? The ratio of the 4 areas will be A squared, B squared, AB, and AB, right? That's the ratio of the 4 areas. Now, how do I use this fact in this question? The way we're going to do this thing is that we're going to split it up along the diagonals. So probably you already guessed, this diagonal is one thing I drew just now. But in fact, we're going to draw this diagonal as well. We're going to draw this diagonal as well. So we're going to split it up into 3 trapeziums. And then I'm going to apply this fact for these 3 trapeziums. Now, do we know the areas of these 3 trapeziums firstly? Do we know? Yeah, we know. This is 1 unit. This is 3 units. This is 5 units. How do I know these 3 areas are 1 unit, 3 unit, and 5 unit? Because of the fact that this one here, if it's 1, then this one here is 4 times as big, right? It's 2 squared times as big. This one here is 3 squared times as big. So if you compare 1, 4, and 9 for the sizes of these 3 triangles here, then you can see that 9 minus 4 is 5. That's this part over here. 4 minus 1 is 3. That's this part over here. So now we're going to deal with the case. If this is 3 units, how much of this is that 3 units? Well, this is a ratio of 1 to 2, right? So let's draw it out at the side. This is 1 to 2. What's going on for 1 to 2? The ratios are 1, 2, 4, 2. So this part here at the bottom is 4 over 9 of the entire area. So it's going to be 4 over 9 of 3 unit is 4 over 3 of a unit. That's this guy right here. Okay. And then now, continuing on, the next part here, this one here, we have a bigger trapezium, right? So let me draw another one here. Bigger trapezium. Is it still going to be 1 to 2? You should say no, right? This part is going to be 2 is to 3 now. So 2 is to 3 is 4, 6, 9, 6, right? The shaded areas I want are the 4 and the 9. So I want the 4 and the 9, which is 13 parts of, how much is this? 25 in total, right? So the shaded part here is 13 over 25. Right? It's 13 over 25 over this trapezium. This trapezium itself is 5 units. I multiply it's 13 over 5. Okay. So now the thing is that, okay, what am I calculating? The area of the shaded region, right? I know that 9 units is this part. So I know that 9 units is half times 90 times 90. So how can I calculate the value of 4 over 3 units and 13 over 5 units? Okay, maybe I just calculate them separately. So if this is 4 over 3 units, what do you do here? You divide this by 9 first. So you get half times 10 times 90, which is 5 times 90, which is 450. So 1 unit is 450 firstly. Let me write it down. Wait, something looks wrong. Is that true? Yeah, this is true. Okay, so 1 unit is 450, and then after that, 4 over 3 unit is 600, I think, right? Yeah. Then 13 over 5 unit is 13 times 90. 117, I think. So together, the final answer should be 1770. Okay, so that is the idea. Right? So you can see that once you know that we are trying to apply this fact into this question, actually the question becomes relatively easy to do. Right? Once you try to apply this fact with trapeziums. Okay. Brian, no, not Brian. Who is this? BF Wang. I don't know who this BF Wang is. BF Wang, can you stop with this? Thank you. Also, for some of you who say, I think if you send more messages, you can get XP. Is that true? But try not to send so many. I don't think it's a good thing to just spam as well. Yeah. Okay. Anyway, let's continue on. Okay, question number 21. So from this point onwards, the questions are going to be a lot more challenging in terms of difficulty. For some of these questions, even if I explain, there's going to be a decent chance that it can still be a bit confusing to you all. So in that case, don't worry too much about it. Question number 21. We have what we call a valley number. Valley number is a number that strictly decreases from the beginning and then strictly increase to the end. For example, 431 decrease, 1, 2, 5, 6, 7 increase. But then 1, 2, 3, 4, 5, 6, 7 is not a valley number because it just goes up all the way, right? You need to have some kind of decrease and increase. Or for example, like a big decrease followed by a small increase. These kind of numbers are what we call valley numbers. So the question in this case is how many valley numbers can be formed? I will provide you with two ideas for do this question, but I'll tell you that the final answer is equals to 62. Okay. So let me present to you the faster idea first. The faster idea for this question is to think, where can a 7 be? Actually, the 7 only has two choices. The 7 must be either at the start or at the end. Correct? The 7 must be either at the start or at the end. Now, if you remove the 7, where can the 6 be? Same thing, it must be either at the start or at the end, right? Because remember, let me try to draw the shape of the valley. Even if you remove the highest point, let's say you remove the highest point of the valley, you destroy this one. The remaining shape still tells you, oh, my number 6 will be at either endpoints, right? For example, your 6 in the example is over here, but what if your 6 was here? What if your 6 was here, then your 5, where's your 5? It's either going to be here or here, isn't it? Your 5 is here. Right. Wait. Just now. Oh yeah. Wait. Sorry. Something is wrong here somewhere. Okay, wait. Let me try to correct my mistake first. Wait. Something says it's wrong. Okay. So I made a mistake for sure. I forgot to multiply by 2. But then, is there anything else I forgot to do? One of you, Yongli, you said 600 times 4 plus 810 times 2. Okay, I don't know where your 810 comes from. Because this doesn't feel like 810 to me. But either way, it's not going to be 600 times 4. Yeah. Okay, so Yongli, the problem you're working is, I think you assume that this part and this part have the same area, but they don't. They don't because this slope here is not the same as this slope. So the two parts here, area number 1 and area number 2, they actually don't have the same area. So you cannot just do 600 times 4. But yes, I made a mistake here. My answer is not correct. My answer, I need to do what? I need to do 1770 times 2, right? Because at the start, I did something. At the start, I did the splitting into 2, isn't it? And at the end, I forgot to multiply by the other side. So sorry about that. It should be 3540 instead. Okay, so yeah. Okay, anyway, let me come back to the question number 21. So yeah, for this question, I was saying that even if you delete, let's say, the two numbers at the back, the number 5 must still be at either one of the endpoints. And let's say the number 5 is, let's say, somewhere here, for example. And even if you delete number 5, the number 4 should be at one of the points. So the key trick for this question is that once you put on the number 1, you have two choices for each of 2, 3, 4, 5, 6, and 7. Right? For example, your 2 can be either on the left or on the right, right? Two choices. Let's say you put on the left. Your 3 can be either here or here. Your 4 can be either here or here. Right, your 5 can be either here or here. Then 6 can be either here or here. And then your 7 can be either here or here, right? So it's going to have two choices for each of them. So that's where the 2 to the power 6 comes from, in case you're wondering. Right? Two choices for each of the numbers. But then, why we minus 2? We minus 2 to get rid of this guy. And also the other guy, 7, 6, 5, 4, 3, 2, 1. This where we minus 2. Because we have to remove the two cases where 1 is at the end. If 1 is at the end, it is not like this. If 1 is at the end, it's either like this or like this, right? So we have to remove them. Finish. 62. So this is method number 1. Okay, then what is method number 2? Method number 2 is that we don't actually need to know about this idea. You're just going to count how many cases. The possibilities are something 1, something, 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 how many? Something like that. So the remaining possibilities, how many do you have? Well, you need 1 digit on the left, you need 5 digits on the right. So how many ways are there to choose the digit on the left? There's 6 ways, right? There's 6 ways to choose the digit on the left. How many ways to choose the digits on the right? Actually, once you choose the digit on the left, there's only one way to fill the rest of it in. For example, if you fill in 4 here, how must you fill in the remaining? Must be 2, 3, 5, 6, and 7, right? If you fill in 4 here. So no matter what digit you fill at the start, you notice that your remaining things are fixed. This is 6, choose 1. Let's say now you have 2 digits on the left and 4 digits on the right. You can choose the 2 digits on the left. But once you choose the 2 digits on the left, what can you see? The number is fixed. Let's say we choose 3 and 7. If you choose 3 and 7 to be on the left, it must be 7, 3. Then 2, 4, 6 belongs on the right. It must be 2, 4, 6. 2, 4, 5, 6. So it must be 6, choose 2. And if you can see, this is where it continues on. This should be 6, choose 3. This should be 6, choose 4. And then finally, last one is 6, choose 5. And when you add up these numbers together, you will also get 62. So now you can see, right? No matter which choice of numbers you choose, you will get the, no matter which choice of method you use, you get the same answer in the end. Both will give you 62. Okay. Question number 22. Find the largest prime number that divides this guy. So what does it mean by divides an expression? So divides means it's a factor. For example, 3 divides 6. Now some of you might be very confused, huh? Isn't 3 a factor of 6? Why you say 3 divides 6? So in general, in people, in Math Olympiad, we use divides. We say it this way. A divides B. So this is the notation. If A is factor of B. Right. So for example, 2 divides 16. But 8 does not divide 4. Okay, now for question number 22, this thing here, I'm not very sure of my answer because my answer is a 6-digit number. So I'm not too sure about that, but let's work it out and let's see if I made any mistakes along the way. Huh? What is the idea for this question? The idea for this question is that each number can be written as n minus 1, n, and n plus 1 multiplied together. And if you're actually going to expand out what this is, it will be n times n squared minus 1, right? If you multiply these two. So this will be n cubed minus n. So now we are trying to take the sum of n cubed minus n across all the values of n. If any of you have seen a notation before, it is actually we are trying to do the sigma over here. That's the sum of all the numbers n cubed minus n. But what are we summing from? We are summing from n equals to 2 to n equals to 2025, isn't it? Right? Here n equals 2, n equals 3, or then n equals 2024, or then n equals 2025. Now, we are going to make a change here. We are going to change from n equals to 2 to actually n equals to 1. how come we can change n equals 2 to n equals 1? Because if you think about it, what happens when n equals 1? That's 0 times 1 times 2, right? 0 times 1 times 2 is just 0. So if I add this to my sequence, no change. But now this is a lot easier to do, because how do you sum up n cubed minus n from n equals 1 to n equals 2025? Well, we just treat it as two separate sequences. There is a 1 cube, 2 cube, 3 cube, all the way to 2025 cube. But we need to subtract away 1, 2, 3, all the way to 2025. Right? So the n cube minus n is present in 1 cube minus 1, 2 cube minus 2, 3 cube minus 3, or then 2025 cube minus away 2025. And now each of these we know how to do. In fact, the previous question in the worksheet tells you how to add up the first part, right? The previous question tells you, one of the previous questions tells you this is 2025 times 2026 over 2 squared, which is 2025 squared times 1013 squared. A very ugly number. Meanwhile, the part behind, that's just equals to 2025 times 2026 over 2, which is just 2025 times 1013. So now something interesting happens. We are now taking this thing minus away this thing. Right? We're taking the difference of these two numbers. And when we are taking the difference of two numbers, what we are thinking of in our head is not actually this thing. We can think of them as a squared minus a. How to deal with a squared minus a? A squared minus a is just a times a minus 1, right? Okay, so a times a minus 1, as a result from here, what we have is going to be a times a minus 1 is this guy times this guy minus 1. Disgusting. Okay, so now what we can do is that we need to try to figure out what this is, because these two are very obvious. This one I know how to factorize. 1013 is a prime number. In fact, we saw this in the previous question already, right? So you just need to figure out how to factorize this. And unfortunately, this is where the question actually, I think either I did something wrong or the question did something wrong or somewhere did something wrong, because this number I'm getting here is what's my working? Let me see my working. This number I'm getting here is some big number. Wait, where is this question? 2041324, which is equals to 4 times, according to Google, it is 4 times 5. Actually, I can do this without Google. no. Wait, what? 510334, right? And 33. Wait, okay. Let me actually prime factorize this again. Wait, so let me ask Google, what is the prime factorization of, what is this number? 2041324. Oh, okay. It's 2 squared times 510331. And then according to Google, 510331 is a prime. So this one is supposed to be the answer, unless I did something wrong in the question. I feel like there's probably some kind of mistake I'm not realizing at the moment. Okay, anyway, 2051324, is it? 20. Okay, let me check again. 2051324. Yes, thanks for finding out. Then it's wrong already. Wait, then I need to ask Google again. Ayo. Okay, ask Google to factorize for me 2051324. Uh, 2 squared times 31 times 16543. Um, I don't know. 16543, I guess. One of you keeps saying n should start with 2. Actually, I did that already. What do you mean by 51281? Where do you get this number from? Yeah, we're doing at Google. So either something is going wrong somewhere, or the competition just expects you to. I don't know what the competition expects you to do actually over here at this time. I have no idea what is required. Okay. But I want to try some other way actually. I want to try to see in another way is possible, because I remember something to do with this. Actually, do I remember? I can't forget. Hmm. Wait, yeah, I did something wrong. Wait. Hmm. But I cannot see what I did wrong though. That's the problem. Okay, let me try to do by another way. Let me try by another way. Try by another way. So another way I'm going to do is to do this using a hockey stick identity. So for what this identity is, it is this thing. 16513 is a multiple of 71. Okay, I don't know. For hockey stick identity, oh yeah, it's 2027. Yeah, okay, I think Yong is correct. So that means I'm not supposed to use this method then. Because somehow using this method, I made some mistake somewhere that made me not able to see that 2027 is a factor of this number. At least not immediately. So here's another way. We can use a hockey stick identity. Now, why I don't want to present using this identity at first? Because this is not something that most of you would know. But what it says is this thing. On the Pascal's triangle, what happens if you try to add up numbers along a certain diagonal? In fact, you can get the answer by looking at another number here. For example, okay, Auntie, we don't need to bring out the summation over here. Okay, your answer is correct, but I want to explain it in my way. So 1 plus 1 plus 1 plus 1 plus 1 plus 1. If I take 7 of them, right, this sum is 7. Okay. What happens if I do 1 plus 2 plus 3 plus 4 plus 5 plus 6? The sum is 21. What happens if I try to do 1 plus 3 plus 6 plus 10 plus 15? The sum is 35. So at this point, can you see something? What the hockey stick identity is saying is this thing. If you try to add all the numbers in the diagonal, it will be the one that is along the next row but moved over. So that is what the hockey stick identity says. And why is it called hockey stick identity? It's because of the fact that if you look at the shape that I'm drawing right here, it looks like a hockey stick. Now, in general, what does it say? In general, if you look at what the numbers in a Pascal's triangle is actually, this is 0 choose 0, this is 1 choose 1, 1 choose 0, 1 choose 1, 2 choose 0, 2 choose 1, 2 choose 2, 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3, and so on. So if I try to add up numbers along a diagonal, for example, this diagonal here, what is it? This is 2 choose 2, 3 choose 2, 4 choose 2, 5 choose 2, 6 choose 2, and then I'll get 7 choose 3. Okay? So same thing here. This is 3 choose 3, 4 choose 3, 5 choose 3, 6 choose 3, and then this is 7 choose 4. So in general, hockey stick identity tells you the following thing. If you do R choose R plus R plus 1 choose R plus R plus 2 choose R plus dot 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 plus all the way until N choose R, you get N plus 1 choose R plus 1. Now, why is this hockey stick identity useful for this question, even though it looks so scary, right? Because the trick is this. This number at the start, I'm going to call this sum s. Instead of doing the sum s, we're going to do something else. We're going to consider what happens if I take s, I divide by 3 factorial. 1 times 2 times 3 over 3 factorial. 2 times 3 times 4 over 3 factorial. 3 times 4 times 5 over 3 factorial. Is there anything that you're noticing? You should notice that in fact all of these are something choose something. The first guy is 3 choose 3, the second guy is 4 choose 3, the next guy is 5 choose 3, or then the last guy is 2026 choose 3. And if I add up all these numbers together, according to my hockey stick identity, it should be equals to 2027 choose 4. And so we know exactly what is s. If s over 3 factorial is equals to this thing over 4 factorial, then we know that in fact s is exactly equals to 2027 times 2026 times 2025 times 2024 over 4. This is the value of s. Okay, so from here we can figure out that actually the largest prime is 2027, because some of you in the messages you told me 2027 is a prime. Okay, so that is the answer. So both of these ways are okay. There's nothing wrong with doing my first method. It's just that my first method, somehow it doesn't tell you the largest prime number. It tells you the answer, right? My first method, I know what the answer is. I know that the answer is this. It's just that in the end, factorizing it is very difficult. So this is wrong, right? Because factorizing is difficult. So there's no answer that you can get here by factorizing, because you get a very big number, right? But if you try to use the other method, then it's already factorized for us in the answer. But the bad thing about this method is we need to use something called hockey stick identity already, right? Some of you probably have not done that before, so that's why we need to actually I need to go and explain what this is all about. Okay, anyway, finally, let me move on. Question number 23, there are 10 distinct points on a circle. We want to pair up these points and connect each pair with a line segment so that no two segments intersect. For example, the figure on the right shows one such pairing method. How many different non-intersecting pairing configurations are there? So try to draw all of them out. You might miss a case or two, or you might not miss a case or two. Then it's alright if you miss them. So what are the cases? Let me try to show it to you. In fact, I'm going to draw the 10 points on the circle first so that it's easier for me to connect them later. How many cases do I have? A total of 5. But in fact, one of them is drawn out for you already. So I'm not going to draw this one. So this is the obvious case. Okay, actually, no, this is not the obvious case. The obvious case, the most obvious case is supposed to be this one. I think this one, most of you probably thought of it already, right? The case where you join each of them to the neighbor, right? It's probably more obvious than this one. But there's actually also 3 other cases in this question. How to figure out the 3 other cases? Well, if I don't want to join each of them to the neighbor, what must happen? This guy, let's say I don't want to join to the neighbor. Can I join this way? No. The problem is that this part here, he has no one to join to, right? He must intersect one of the existing line. Problem. Okay, come back to this guy again. Can I join this guy with this one? Can. In that case, this one on the left must be joined together, right? Then how do I join the remaining 6 people? One option is I do this, this, and this. So from there, we have another way already. Like this, this, and this. Right? Get the point. Is there any other way to do it? If I have 6 people like this? But if I choose this guy again, I could join this way. Then I must join this way. I must join this way. It's this guy, right? But actually, there's also a second case. If I join this way, I can choose for the remaining 4 people to be joined this way and this way. So that's another case. But there's one last case that is very easy to miss out. Remember at the start, we assumed that this guy is joined here, right? But he doesn't have to be. We discussed the case where he's joined to his neighbors, joined to this one, and joined to this one and this one. There's still some cases we haven't explored. What happens if it's joined here? If it's joined here, then there's 3 people on the left. Cannot. We need an even number on the left, right? So the only case left over is when you join this diagonally across. But you need to avoid cases which you have already done, which is here and here. Is there any case that you can come up here that is not already done? Turns out there is. There's this one case as well. And by doing so, actually we figure out all the possible cases in this question. Now we just need to figure out how many ways are there. Okay, so let's do the one in the question in the big diagram first. How many ways for this? The answer is 5. Why does this only have 5 ways instead of 10 ways? Right? You might be thinking, it's 10, but no, it's 5. The reason why it only has 5 is because the other pair is 10 and 1. One pair is 6 and 5, one pair is 10 and 1. Right? So the pairs can be here, 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 or here and here. And then you come back to the start again. So there's only 5 ways. What about this one? How many ways for this one? 2 actually. 2 because of the fact that you don't have a choice. It's either you go and do this guy with his left neighbor or right neighbor, or this guy with his other neighbor. 2 choices. How many ways for this one? This one is 10 because this one here and this one can get rotated. So you can get rotated to here, here, right? Or for example, like here, here, and so on and so forth. There's 10 ways. In a similar manner, this one also has 10 ways. And finally, what is this guy? Once again, it is not actually 10, it is 5. Because the main diagonal is the one that decides everything. The main diagonal can be here, 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 or here. There's 5 main diagonals, this one is 5. Final answer, 2 plus 10 plus 10 plus 5 plus 5, 32. Okay, continuing on. Okay, question 24. Among all the questions from question 21 to 30, this is probably the easiest one. A library has 100 books in total. And then from the fact that ABC borrows some number of books and A and B together they do something, B and C do something, C and A do something, you should really think about doing a Venn diagram. Right, a Venn diagram makes a lot of sense for this question. Okay, so A has 33, B has 44, C has 55. A and B borrowed 29 books. So 29 is where? 29 is here. Right, 29 is here. And then A and C borrowed 25. So 25 is here. And then B and C borrowed 36. 36 is here. Okay, so this is what they have. And I want to find the maximum number of books that were never borrowed by any 3 people. So if I want to have the maximum number of books that were never borrowed by any 3 people, what do I want? I want the minimum borrowed by all 3, right? Maximum never borrowed means I want the minimum borrowed by people, not all 3, by people in general. So I want to minimize the number of people I put here. Okay, wait. Some of you are telling me there's one more case for question number 23. Let me just check. One more case. How to get one more case? Oh, I see. I see what the last case is. Yeah, I see what the last case is. Sorry. I somehow didn't see this just now. Somehow in my arguments, I missed out this case completely. I think it's something like this and this. Is that correct? Is that the case I missed out? Yes, right? I think this is the case I missed out. Yeah. Thanks for y'all for pointing out. So actually it's supposed to be this one, there's 5 ways. No, this one is, I don't think it's 5. This one is 10 ways. So the answer is supposed to be 32 plus 10. 42. Yep, sorry about it. Okay, anyway, let's come back to this case again. So how do I find out the minimum borrowed by people here? I want to actually figure out the minimum across this. Now, what happens if you take 33 plus 44 plus 55 minus away each of these numbers? If you take these three blue circles, you add them together, you minus off the brown color, the red color, and the green color, you actually get something. You get the entire region minus off the central location. Okay, so let me repeat that again. Let me write it out for you. In fact, if you do 33 plus 44 plus 55 minus 29 minus 36 minus 25, the area that you get is everything here minus the center. Okay, that comes from this number. Now, what am I supposed to do here? Okay, so this is a fixed number. This is whatever the number is. So if I want the minimum, I want to minimize the number of people in the middle. So therefore, in the middle, I must have the minimum. Because I know that whatever's on the outside will add up to give you this number. So I want to put as little people over here as possible. How many ways can I do that? Okay, I didn't think about this beforehand, but so to figure that out, can I put 0? Of course cannot, right? If I put 0 here, there's 29 here, there's 25 here, there's 36 here. The problem is that 25 plus 36 is 61, it's more than 55. 29 plus 36 is 65, it's more than 44. 29 plus 25 is 54, it's more than 33. So let's try something else then. What happens if we try 10? Then this is 19, this is 15. That is 34, still a little bit too much. What about here? This is 45, it's still a little bit too much. So now I'm thinking if I try 11, it should work, right? Because if I try 11 in the middle, then this is 18, this is 14, this is 25. Does this work? Oh no, wait, this is how many? This is, no, sorry, this is 43 now, and this is 54, sorry. Instead of 11, I should try 16 then. Okay? No, I should try 21, right? If I try 21 here, then this is 8, this is 4, I get exactly 33. Can you see that? I get exactly 33. And then after that, 44 minus 36 minus 21 is 15. And in fact, yes, 8 plus 21 plus 15 is exactly 44. Yeah. So in the middle, I should actually put 21. So that's how we do it. Basically gets in check. Okay. And in the end, you can see that it works because you can have 21, 8, 4, 15, and whatever number is left over here. I don't know what this is. But this will be 0 and this will also be 0. Interestingly. What's this number? I cannot math all of a sudden. 15, right? Hopefully this is correct. Okay, but either way, you can see that there will be 55 people in this circle. There will be 8 people here. So the minimum borrowed by people is 63. You need to borrow at least 63 books. So the maximum that's never borrowed by anyone is 37. Finish. Okay, question number 25. Another question which is I don't think is too difficult. So here you have 4 integers. The meaning of the word coprime, sometimes you see this, it also means relatively prime. Relatively prime means that the numbers, they cannot share any common factors other than 1. For example, relatively prime numbers will be like, let me give you an example. 4 and 9 are relatively prime because they don't share any common factors other than 1. Even though themselves, they are like not prime numbers. Something that is not relatively prime, sometimes we also call it not coprime. For example, 17 and 34, they are not prime because 34 is a multiple of 17. Right? So you can have numbers that are prime but also not relatively prime. So you just need to make sure that each of these three pairs, they share common factor other than 1. And then you need to make sure that the other pairs, they don't share any common factor. So let me draw that out. So x and y, they must share a common factor. Y and z, they must share a common factor. Z and w, they must share a common factor. Now, here's the thing. Can all these common factors be equal to each other? Cannot, right? Because of the fact that if this is common factor of 2, if this is a common factor of 2, then x and z are both even numbers. X and z themselves also have a common factor of 2. Using this reasoning, if the common factor they have is p, and the common factor they have here is q, and the common factor they have here is r, p, q, r, they cannot share any common factors. Right? They cannot share any common factors because of the fact that if they share common factors, for example, x and z will also be common factor, right? So p, q, r are all coprime. In fact, you can use the same term used in this question. And the best way to make sure that the numbers are as small as possible is that I choose p, q, r to be all primes. If I choose them to be all primes, it's as small as possible, right? If I choose, for example, 2, 3, 5, it's a lot nicer than choosing, for example, 4, 6, and 10, isn't it? Now, which one you want to choose to be 2, which one you want to choose to be 3, which one you want to choose to be 5? Well, the smallest choices you can have for each of them is p for x, p times q for y, q times r for z, and r for w. How do you choose 2, 3, and 5 among these three letters so that this sum is the smallest? Answer, you want to choose q to be 2. If you choose q to be 2, this sum here will be smaller than if you choose p to be 2 or than if you choose r to be 2. If you choose q to be 2, the answer is 3, 3 times 2, 5 times 2, and 5. The sum is exactly equals to 24. If you don't choose q is 2, if you choose q equals 3 or anything else that's bigger, your answer will also be bigger. You don't want that. Okay. Continuing on, question 26. I haven't had time to try this. How many triangles are there? But I feel this is a relatively standard kind of question because what you just do is you count by the sizes. So size 1, size 2, right, size 4. I think is there any size 8? Let me take a look at the diagram first. How do you have a size 8? Size 8 is like this, right? Oh, there is some kind of size 8. There is some size 8 here. I can see it. So there is size 8 as well. I'm not going to bother to draw it out. Size 8. Is there any size 16? No. But here is where you might make a mistake. You might think that just because there's no size 8, you stop there. But the mistake that people can make for this question is they can forget about a size 9 triangle. Where's the size 9 triangle? Here. This is a size 9 triangle. Okay. I believe that that's everything. Let me do a double check. Yeah, I think that's all. So the only sizes are 1, 2, 4, 8, and 9. Okay, how many size 1 are there? 2 times 16. This is 32, obviously. How many size 2 are there? There's 1, 2, 3, 4 for each of them. So that's 16. And then what else? 17. Actually, the middle also has 4, right? 17, 18, 19, 20, 21, 22, 23, 24. I think that's everything. Right, 24. Size 4, how many are there? Size 4 must be in this kind of shape. So size 4 must be something like this, for example. So the first size 4, in fact, is okay. Let's look at those size 4 that are facing on the bottom right. So the bottom right corner is the right angle. So the bottom right corner is the right angle. There's 1, 2, 3, 4. There's only 4 of them with the bottom right being right angle. So therefore, there's 16 of them total. Right, 4 times 4. Okay. How many size 8 are there? Size 8, I think there's only 4. There's this one, and then the other are this thing but turn around, right? Like that, for example. There's only 4 of them here. Size 9, there should also only be 4. No. Size 9, there are 8. Because if you look at those, they are pointing bottom right corner as a right angle. There's one here and then there's one here. So these are the two triangles that are pointing bottom right. So 2 times 4, 8 of them. Okay, so the sum is what? I cannot math. 32, 32, 64, 80, 84. Okay, I know that it's pretty late already. There's only 4 more questions to go, huh? Unfortunately, oh, the last hole is absolutely disgusting. Okay. Question number 27. How many 6-digit numbers are there such a product of digits is 6 to the power 6? Why is this question so disgusting? Because there's so many cases that this can work. 6 to the power 6 is equals to 2 to the power 6 times 3 to the power 6. What we do is that we split the 2's and 3's into the components. We ask ourselves, for the numbers for the digits from 0 to 1, how many 2's and 3's do they actually give you? Now, those that can only give 2 and 3 are 1, 2, 3, 4, 6, 8, and 9. 1 gives you nothing. 2 gives you 1 of 2 and 0 of 3. 3 gives you 0 of 2 and 1 of 3. 4 gives you 2 copies of 2 and 0 copies of 3, and then so on. The main thing you want to start from this question is the copies of 3. You need to think to yourself, how do you get 6 numbers and then multiply together you have 6 copies of 3? Okay. So what we have here is that we can choose, for example, 999. Right? You can choose, for example, 999, because if you choose 999 already, you don't need to have any more 3's inside your number. Then what do you do for the rest? The remaining, you just need to get the 6 copies of the 2, isn't it? So for example, one way is to do 444, right? But what about besides 444, any other way? You can also get 6 copies by doing 3, 3, and a 0. So it could be 9, 9, 9, 8, 8. And then this one here could be oh no, the 3's are already done, right? The 3's are already done. You cannot take any more 3's. You cannot take any more from here. You cannot take any more from here. You must take this one. It must be 9998881. That's the only way. Okay. How many ways are that? You can also take a 3, a 2, and a 1, right? So you can also take 999842. So these are the ways you can get 3 copies of 6 copies of 6 and 6 copies of 2 and 6 copies of 3. Okay, so yeah, these are the cases of 999. What else do we have? If you don't choose 999, you can choose 99 together with a 6 or a 3. 996. Oh, okay. If you choose 996, you need one more copy of a 3 from either here or here. So you can choose 9966, 9963, or 9933, right? To give you all things. If you choose 9966, you need how many? You need 4 more of this. 4 more from remaining is either 82 or 44, right? If you choose 9963, you need how many? 5 more copies. 5 more copies from here must be 84, in fact. If you choose 9933, you have nothing here. You need to get 6 copies of 2. The only way to do it is 88. Okay, continue on. If you only use 9, is it possible? Is it possible you have 9, 6, 6, 6, 3, and something else, for example? Because neither you have 6 copies of 3 as well, but then now you have you need 3 copies of 8. 3 copies of 2, which makes it the last one 8. So that means that if it's 9, 6, 6, 6, 3, 8, then the other possibility is 9, 6, 6, 6, 6, 4. And it's not possible for 9, 6, 6, 3, 3 something, because the remaining one will be 16. And finally, the last one is obviously just 6, 6, 6, 6, 6, 6. Right? Because if you don't use any 9s, all of them must come from here. Okay, so we have finished this thing out. Okay, now let's count how many of each of them there are. This is obviously 1. This is 6 times 5, there's 30 of them. No, wait, that's not true. This is 6 choose 1 times 5 choose 1. Yeah, actually it's 30 of them. This is 6 times 5 times 4. This is 6 choose 2 times 4 choose 2 times 2 choose 2. This is 6 choose 2 times 4, 3, 2, 1. Right? Oh, this is how many? 360, right? This is 6 choose 2 times 4 choose 2 times 2, which is equals to, it's just this number times 2, right? 180. This is same thing as this basically, right? 6 choose 2 times 4, 4 choose 2 times 2 choose 2, this is 90. This one is 6 choose 3 times 3 factorial. 6 choose 3 is 20 times 3 factorial is equals to 120. This is 6 choose 3 times 3 choose 2 times 1. This is 60. And finally, this is just 6 choose 3 times 6 choose 3 only, 20. Yeah. But let me see if I made any mistakes somewhere. 6 choose 2 times. Oh yeah, I made mistakes. Okay, so this is wrong. Because, how do I explain why this is wrong? Because here I did 6 choose 2 times, I did what? I did 6 choose 2 times 4 choose 2, right? But here it's wrong because I could choose starting from the 2 3s and then followed by 2 8s, for example. If I choose 9 9, 3 3, and then 8 8, it's the same as choosing 3 3, 8 8, and then 9 9. Hopefully you can see the thing. So because of that, I need to further divide this by 6, which is 15 actually. There's only 15 for this. And then I need to further divide this by 2, so this is only 90, for example. Okay, it looks very tedious and very complicated, but then the final answer will be the sum of all these numbers. So 20, 90, wow, so many. Okay, let me try to create a new page. Okay, so what I have, 20, 60, 120, 15, 90, 360, 15, 120, 30 and 1. So that's the final number. Wow, this is big. How much is this? 1. Oh, I'm lost. 10, 20, 30, 3. 8, 8, 3, 1. Okay, I really dislike this question and it wastes so much of my time. But anyway, I hope you roughly understand the idea. Meanwhile, question number 28 is a lot nicer of a question. I like this question a lot more than question number 27. So they give you an isosceles triangle, 5, 5, 6. By the way, just for fun, actually for this triangle 5, 5, 6, it's very, very easy to find the area. Because why? Because if you divide it vertically, it must be a 5, 4, 3 triangle and a 5, 4, 3 triangle. Okay. But anyway, that's not what the question is asking for. The question is asking for the region, the probability that PC is less than PB less than PA. So where are the point P so that PC can be less than PB less than PA? Firstly, this one is easy. PB less than PA. Where is that? Well, you just draw a straight line through here. PB less than PA must be all those here, right? Because they are closer to P than to A. So everything on this side is PB less than PA. So we are done with this. What about PB bigger than PC? The idea is to draw what I call a perpendicular bisector. We draw a line perpendicular to this and splitting it in half. So somewhere exactly here. This is what I call a perpendicular bisector. And then now, the part that we want is this thing. The probability, very simple. The probability is just the area of this region over the area of the entire thing. And I told you what's the trick for the entire thing, right? The entire thing is just, you treat it as 2, 5, 4, 3 triangles. The area is half times base times height, 12. But what about the area of this piece here? Well, we know that on the right side, it is 2.5 And since we know that this is a similar triangle to the original one, this is also a 5, 4, 3 triangle. And if this is also a 5, 4, 3 triangle, then this side at the bottom is 3 over 4 of this side here. So it will be 3 over 4 of 2.5. The area of this part in green color is half times 3 over 4 times 5 over 2 squared, which is disgusting. This is 75 over 32. Yuck. But anyway, now we know the final answer. The probability is the area of the one that's green color divided by the area of the total. So this is what? This is 25 over 128. So then m plus n is 153. Finish. Okay, last two questions. Second last question. In fact, I don't have the answer for question number 29 yet. So I'm going to jump to question number 30. Because at the moment, I don't know how to do this question yet. So I'm going to jump to question 30. I'm going to come back to this question later. So, you feel that he's forced to say that. I agree. I feel that he's forced to say that too. Okay, an arithmetic sequence is a sequence in which the difference between any two consecutive terms is constant. For example, this has a constant difference of 2. It's an arithmetic sequence. This has a constant difference of negative 1.5. So this is arithmetic sequence. Find the sum of all possible first term of these good sequences. So it must contain both 20 and 26. What is the idea behind this? The idea for this question is to use symmetry. How to use symmetry to do this question? If you take a look at this one here, I can actually generate you a sequence that is symmetric to this. I just flip the 26 and 20 around. I do 28, 26, 24, 22, 18, 16, 14. These two are symmetrical. Why are they symmetrical? They are symmetrical because of the fact that 20 and 26 are in the same position for both of them. Now, when you have symmetry, it's a very nice thing. Because even without finding out what the first number is, you can tell that they'll add up to 46. Because this adds up to 46, 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 46, 46, 46. So let me show you for the other one. For the one behind, you start with 20 and then have 26 over here. So it'll be 20, 21 and a half, 23, 24 and a half, so on and so forth. Again, you can see this adds up to 26. Sorry, this adds up to 46. So this will also add up to 46. So by pairing, we get 46 as a sum of each pair, right? If you look, this original sequence, I pair with the symmetric sequence, the sum here is 46. This is the original sequence, I pair with the symmetric sequence here, the sum is 46. So I just need to do what? I just need to find how many pairs there are. Right, I just need to find how many pairs there are. So the number of pairs can be found by looking at where the positions of 20 and 26 are. There are 8 positions. So there's 8 choose 2 possible locations of where 20 and 26 could be. Once we determine, for example, 20 is here and 26 is here, what do we have? I know that those two sequences, the numbers in front will sum to 46. So answer 8 choose 2 times 46. Finish. Okay, 28 times 46. Let me calculate that. 1288, I think. Yeah. Okay. So now I'm left with one question. One of you seems to have some kind of idea. Let me see if I can use your idea. Question 29, try to get 6 numbers from 1 to 10 so the LCM is lowest and use 4 from remaining 4. Yeah, so Jingwang, I have the same idea as you. But then the remaining 4, you need to make sure that the divide by 1 is going to be what? It's going to be remainder, sorry, divide by the number is going to be remainder 1, right? Okay, let me show you question number 29. So you want to figure out when this adds up to 4. So each of this is m divided by 1, m divided by 2, m divided by 3, or then m divided by 10. These remainders must add up to 4. One idea that you might have is start with one possible choice of m. You might want to try m equals to 1 times 2 times 3 times 4 times what? No, not this one. M equals to maybe LCM of 1, 2, 3, 4, 6, and maybe, is it 8 or 9? Maybe let's choose 8. Right. But then the problem is that it's somehow also divisible by 9, and then you need to go and modify it so that the remainders for 5, 7, 10 add up to 4. Right? Do you get what I mean? Not so obvious. Right? Not so obvious. Yeah. In fact, if you choose, how do I say this? In fact, can you get 4 ones on the left? The answer is not possible. Because if you choose 4 ones on the left, it must be from divide by 3, divide by 5, divide by 7, and divide by 9. How come? Because if you have 4 ones on the left, then the number itself is even, because 2 is one of the factors, right? But if the number itself is even, then if I try to do, let's say I divide by 10, it must be a remainder of an even number then. Right? The number itself is even, so if I divide by even number, the remainder is also even. So the only way this can be 1, 1, 1, 1 in some way is to do divide by 3 remainder 1, divide by 5 remainder 1, divide by 7 remainder 1, divide by 9 remainder 1. But that's not possible, because like that it tells you that actually it's a multiple of 10, right? Because divide by 10 remainder 0 is a multiple of 10, so cannot divide by 5 remainder 1. So I'm gonna try. Yeah, I'm gonna try something. I'm gonna try divide by 5 remainder 1, divide by 7 remainder 1, divide by 10 remainder 2. I'm gonna see how big this number is before I decide whether there's any other possibilities. So m itself needs to be a multiple of this, for example, right? Together with 9. So 72. 72. 72. And a number that is divided by what? Divide by 35 remainder 1. A number that divided by 35 remainder 1 and also a multiple of 72. What would that number be? 72 and... Okay, for most of you here, actually, y'all can log off the stream already, because at the moment, I don't know how to do this question number 29. So there's no point for you to continue stay here and watch the stream. Y'all can go rest for tonight. So I'm only here to see if I can finish figuring out how to do this question, which I don't think I can. 72n divided by 35. 1. Okay, so one possibility is 18 times 72. 18 times 72 divided by 35 is remainder 1. But this is a very big number. Is there anything that's smaller than that? If I don't choose 1, 2, 3, 4, 6, 8, and 9, if I include 10, what happens? If I include 10, for example, now I don't choose 9, then maybe I also don't choose 8. Then maybe I only stick to this one, 5 and 10. Maybe. Let me try something else. Let me try divide by 7 remainder 1, divide by 9 remainder 1, divide by... Oh no, that's not possible. Because if you divide by 9, it must be a remainder that's a multiple of 3, right? If it's a multiple of 3 and 6 already. So then this must be 3, then this must be 2. Cannot. So it cannot be 7, it cannot be 7, 8, and 9. So we cannot choose both 8 and 9 outside basically. If you choose 7 and 8, you can only choose... Wait, is 5, 7, and 10 the only way? Because you cannot choose, for example, 7, 8, and 6 either. Because this will be even, this will be even, and this one needs to be like a 1. Or maybe you can choose 8 and 6, but then you make your original number a multiple of both 7 and 5. But that's very big already, right? That's very big. That's definitely bigger than this number. Okay, sorry. I mean divide by 8 and divide by 4. Let's say remainder 2, then 2, 9, 5, 7, 10. How big is this number? Is it smaller than this? No, it's bigger, right? Yeah, that's too big. So it feels like 5, 7, 10, remainder 1, remainder 2 should be the smallest case. But there's no guarantee that this is the smallest number. In case you're wondering what this is 36 squared, this is 1296. So I think that 1296 should be the answer, but I cannot confirm whether this is true or wrong. Yeah, 7 should definitely be outside. It definitely feels that it makes sense that 7 and 5 should not be in the number. Okay, I just have to accept this vague feeling then. So let me just end it here, but then ask Google. Actually, good idea. Maybe I'll ask it right now. Since you are here in the stream, let me ask it right now. So okay, let me create a new empty page to ask. I want to see what the answer is actually. Copy current background. Oh. Let me copy and paste this into some of the generative AI. DeepSeek. Why got some promotion of DeepSeek? Okay, Gemini, DeepSeek. Okay, yeah. Why got people say 120? 120 is way too small. There's no way this is 120. Hey, wait. What if it is 120? Wait, let me check again. What if it is 120? So 120 divided by 7 remainder 1, right? What other problems does 120 have? Divide by 9 remainder 3. Wait, is that it? What? That's it? 120? Wait, what? That's it, right? Because it's a multiple of 1, 2, 3, 4, 5, 8, and 10. It's also a multiple of 6. It divided by 7 remainder 1 and divided by 9 remainder 3. That's it. Wait, what? It's actually 120. Wait, let me check my AI. Yeah, they say 120. What the? Okay, I would have never found this 120 by myself. I can tell you that much. Yeah, I would have never found it by myself. Okay, anyway, hopefully you can understand why 120 works, but I cannot explain to you how to come up with this number. It's just, you try this number, you notice that divide by 7 remainder 1, divide by 9 remainder 3, and it happens to be multiple of all of the rest, so it works. Okay, ChatGPT and Gemini both say the same thing, 120. Okay, anyway, then that's all for today then. Hopefully you get a good rest. It's pretty late already. I need to go eat dinner as well. And that's all. Let me stop my stream sharing. If any of you want to stay back